Okay, so let's actually go to a clicker question now on radio probability distributions. So I mentioned you should be able to identify both how many nodes you have and what a graph might look like of different radio probability distributions. So here, what I'd like you to do is identify the correct radio probability distribution plot for a 5s orbital, and also make sure that it matches up with the right number of radial nodes that you would expect. All right, let's take 10 more seconds on that. This should be a quick identification for us to do. All right, so it looks like 82% got the correct answer here. So you should know that there's 4 radial nodes, right? We have 5 minus 1 minus L. Is there a question? It is very difficult for me to draw graphs on the computer. That's a good point. I'm sorry. This was my best attempt at hitting 0 and not having the graph go down there. I'm not the most gifted at drawing on the computer. So yes, it should be 0 at 0, but I made the line too thick. So yeah, so assuming if anyone got it wrong because of that, that's my apologies. That's my fault. But you should see that there are 4 radial nodes here since we have a 5s orbital. And also that we know that the 0 does not count as a node if, per se, I actually had managed to hit 0 in drawing that. So the correct answer would be the bottom one there. So you should be able to generally identify and draw, the general form of these radial probability distributions. Obviously, we don't expect you to know exactly what the distances are, but you should be able to compare them relatively. Yes? No, they actually don't. And when you graph it all out, you can see this if you look at some examples in your book, actually. So this doesn't fall, for example, at 6 A0. But that's a really good question. And the trend always is that the probability gets smaller with each of the peaks as you're drawing them.